Since we're starting this from scratch, let's write out that e of x is root x, and that the I of x is 3 to the x plus x to the 6th. We'll check on the composition here on this line as well, e of I of x. This will hopefully give us back what f of x is. So this should be e of, and replace the I of x now with what I of x is equal to, 3 to the x plus x to the 6th. Now we apply what the e function does, right? So e of an input is root the input. So e of this input, what's in parentheses, is root that input, 3 to the x plus x to the 6th. That, in fact, does give back what f of x is. So cool. The composition works out the way we need it to. Now for derivatives, e prime of x, I prime of x. For e of x, let me just up here, let's just rewrite this as x to the 1/2 power. And so then for the derivative, using the power rule, 1/2 x to the negative 1/2 power. For I prime of x, we'll have 3 to the x times ln of 3 plus 6x to the 5th. So the first term needed the exponential rule, and the second term needed the power rule. For f prime of x, then, we'll just first quote the chain rule directly. E prime of I no prime of x times I prime of x. And then if we copy the e prime of, because we're not ready to process that yet, now for I of x, copy in the 3 to the x plus x to the 6th. That was taken from right here. And then we need it times by I prime of x, which is down there. It's two terms, so we are going to need to wrap in parentheses 3 to the x times ln of 3 plus 6x to the 5th. We're so close to done. Now we just need to process what this e prime does. And what e prime does is e prime of a thing is 1/2 times thing raised to the negative 1/2. So we'll have 1/2, just copying that 1/2, and x is getting replaced with what's in parentheses here. So 3 to the x plus x to the 6th raised to the negative 1/2 power times copy what's in parentheses from before. 3 to the x times ln of 3 plus 6x to the 5th. For the last one, the external function is x to the 15th, and the internal function, I of x, is 12 to the x plus 13 times log base 14 of x. Let's just check the composition on this line, that this works out. So e of I of x is e of, replace the I of x with 12 to the x plus 13 times log base 14 of x. And then let's just do what e does. So e of a thing is thing raised to the 15th. So the thing is what's in parentheses here. So this thing, that thing raised to the 15th. And this is right here, in fact, exactly what f of x is. So the composition work, let's just make sure we can differentiate e and can differentiate I. Right? So for e prime, we'll have 15x to the 14th, direct use of the power rule. For I prime, the first term, we use the exponential rule, 12 to the x times ln of 12. For the second term, we need the constant multiple rule, which lets us copy down the 13, then times by the derivative of log base 14 of x, which is 1 over ln of 14 times 1 over x. Now to do the requested derivative, f prime of x, right? Find f prime of x using the chain rule. I'll just directly, just like here, I'll just make the, write in the generic thing that the chain rule gives us. E prime of I no prime of x times I prime of x. That's not problem specific. That's just generic for any composition to take the derivative. And now e prime of, replace the I of x that appears right here with the I of x that we have. I'll circle it right there, 12 to the x plus 13 times log base 14 of x. Then we're going to times by, and then we've got here I prime of x, and that is all of this stuff right there. So I just will copy down 12 to the x times ln of 12 plus 13 times 1 over ln of 14 times 1 over x. Now the thingy is, what I just wrote down, the thing we're multiplying by here happens to be two terms separated by this plus sign, and for order of operations to work, this has to be in parentheses. Last For our last step, we're just going to process what e prime does. So e prime of a thing is 15 times that thing raised to the 14th power. So 15 times that thing raised to the 14th power. So there's our e prime of that input there, right? And then times just all this stuff. So just copying in the 12 to the x times ln of 12 plus 13 times 1 over ln of 14 times 1 over x.